really interesting because we move now. Thanks again. We move now from the module to the packaging, which is really crucial. Probably many many EPCs have developed at some point in, at least if the career is somewhat longer, some delamination issues over time in modules. So we have to take a close look into the quality of packaging materials. A lot has been happening. If you look at all the different options you see with backsheets and the different trends that we're seeing, it will be interesting to hear from Stephen Gong what's the latest in terms of encapsulation and backsheet trends for utility scale modules. Stephen, the floor is yours.
Yeah, good afternoon, everyone. So the last topic for today is my topic for the encapsulation and the backsheets for utility scale modules. I would tell you 4 major topics about the PVDF revolution from CYBRID'S and also the encapsulant film revolution. Also the transparent backsheet solution now, that is very hot topic. The last topic is a black backsheet with a higher reflectivity pattern solution from CYBRID'S. Yeah. You see, this is the PVDF revolution from the past 10 years, from 2011 to now, due to the cell technology is always updating, and also a big change from the size, also from the ribbon technology, because of the high efficiency cells that they introduced different welding technologies. Before that, the PVDF was a standard normal fluoropolymer that was widely used for glass backsheet modules. But now it is still using, but the cells has changed a lot. Now start to be round ribbons or triangle ribbons or flat ribbons plus the triangle ribbons. So this is a challenge for the PVDF because you know that height of the welding ribbon is has an influence to the backsheet, also the outer layer of the PVDF. So that's why PVDF has been improved to the 2nd or 3rd generation property with lower temperature resistant type. Means that it has a -40-degree elongation break of TD direction more than 30%. Also, that is also applicable for the round welding ribbon and triangle ribbons. For this point, that your module can pass the TC 200, 400, even up to 600 to avoid the outer film cracking issues. Yeah, this is a brief introduction of the film revolution story. These slides I show you the encapsulant film also changed a lot from the 1970s till now. Before it was the US or Japan made EVA was the dominant material for the module encapsulant. Later it was TPO, PVB, or even the liquid silicons was also used for module mass productions. But we know that with the module technology and the higher efficiency change, there are wide EVA or POE that was made purposely on the PID issue. Later, people invented the EPE. Also, CYBRID was one of the company that created a new version EPE to solve the lamination issues and also to prevent the PID issue on PPROC cells. And now it seems that the EVA and EPE dominate for the glass modules, and the clear EVA and white EVA are the major encapsulant for the glass backsheet modules. We also developing something new for the future encapsulant solutions. So let me introduce you in the last topic. This is the transparent backsheet solution from CYBRID. We have 3 solutions to the market and also our customers. We can make a total transparent backsheet is a KPF structure. Also, we make a white grid on the inner side to do a white grid transparent backsheet. Later, people thinking the transparent backsheet, but they want to put on the rooftop. So we made a special black grid on the transparent backsheet inner side. All these 3 backsheets are selling to the market to module solutions. There are one point for the transparent backsheet. People always like that it is aesthetic issues, but sometimes people want the transparent backsheet to replace the glass module they want to put into the Gobi Desert to the some areas that is with the dust, more dust area or strong wind area. So we made interesting testing that is called the sand blowing test for the transparent backsheet. This is a test that is 30 meters per second speed of the wind with 10 gram sand inside, and the sand is attacking the backsheet air side to know if there are the transmission dropping or not. So it is interesting that the coating type is very not let's say is dropping too much after this test. So we suggest that if you want to put a transparent backsheet modules on the strong wind or strong sand areas, it's better to use a test like this to simulate the sand blowing test. Also, another interesting test is the sequential test we did at the beginning of this year. People always do a single agent test like DAMP-HEET or UV, but it is a test that was raised from another third part that they created this sequential test, DAMP-HEET after UV, then you do TC, then do UV, or it's changing the condition of the test. So it is also interesting that we see some of the backsheets they can't go pass through all the tests, so they getting cracking after the 4th step. They start to be cracking a lot. So it is an interesting test because the module in the outside is not only the constant temperature or humidity. So introduce this sequential test. Maybe it is a good way for you to judge it is better or not. The next topic is the black backsheet with higher reflectivity, with a patterned version on top. I show you one scheme that is the standard black backsheet is widely used in the PV industry, but from recent years we made a solution for the black grid, because the bifacial cells was really different from the previous single side cells. It has infrared goes through the cells and then reach the backsheet, and also the rear side can create some powers on the module. So the grid was really how to say a good solution to the bifacial and black modules. This type of module was widely used on the rooftop. Later we did higher reflective version on the black backsheet. You see the right graph. The standard black backsheet reflectivity is close to 0. Then this higher reflective version has around the 50 to 60% reflection at 730 to 1100 nanometers. So this white, this black higher reflectivity version was used to make a black backsheet. This is data that we did a module level comparison compared to the standard black backsheet with bifacial cells, and also standard black backsheet with traditional cells. This is a black grid with standard bifacial cells, and this is with a higher reflectivity version black backsheet. You see the power increase was really good, up to 2.15% increase on a 320 watt module level. So if you put on a 400, 500 module level, you would get more power compared to the standard black backsheet modules. We also did some research for the higher reflectivity version black backsheet. We made a test on the after pressure cooker 48 hours, and also a baking test after 48 hours under 170 degree, also damped 2000 hours. We made FTR, we made reflectivity, we made also color change. You see all the results shows that our higher reflective version. Another topic is always fluoro or non-fluoro. They reach 2020.7 and banned the PFOs for the, and also its salts are listed in for the electronics. So we, you know, the fluoropolymers has a issue of burning that creates the toxic gas like HF. This is a serious pollution to the air, and also when the fire happens, the firefighters were not able to put out the fire in time. So the backsheet
Hi Stephen, you're breaking somewhat off sometimes. Maybe you switch off the camera so that we have more bandwidth for your presentation. Thanks.
Okay. Yeah. We are thinking about the roof, the residential solution to the for the backsheet. There are 5 points that it is different from the ground installations compared to the UV heat resistance and also the humidity on the roof, also the fire protection rate and the recyclabilities. The rooftop is not a module is not a higher request on the ground module. So we had a suggestion for the UV and also the performance should be acquired when you select a better backsheet for utilization. Yeah, we did one type of PPF structure for the rooftop solutions was based on the PET adhesive PET 250 and also a coating net with a non-fluoro type. So this type has been widely used in Europe and also in other countries for the large scale modules. Yeah, also we had a long experience for this kind of film that has a good performance on the module level. Yeah, for the PPF type backsheet, we have 3 suggestions for the customer to choose the different encapsulations setup. You can use transparent EVA plus white EVA. You can use transparent EVA plus a UV cut EVA to use a backsheet with a black grid. Or you can use transparent EVA with a UV cut EVA or even POE to use a high reflectivity and black pattern version for your module to lamination. Yeah. The last topic is the encapsulation solution I have mentioned because each customer they are selecting different encapsulants for their module. They can select EVA or POE or co-extruded EPE or other structures. We know that different films has a different properties. If you see the radar chart, we know that POE has a good resistance of a PID. EVA it has a disadvantage of creating the acetic acid. So later people invented the co-extruded type EPE to solve the problem of lamination issue of POE and also the EVA problem of higher water transmission and also other issues. So we see that the co-extruded type EPE has been growing up rapidly, very rapidly, up to 70% market share till our investigation. Yeah. Also, the EVA, POE, or EPE has a concern about and people also want to optimize the lamination issue, the PID issue, and the cost issue. But I can tell you now, in the market of China, also we ship to the overseas market. EVA plus EPE is now dominating the module lamination encapsulant setup. These two are getting bigger and bigger. POE are using less and less because of the movement issue during the module manufacturing process. Yeah. Also, for the PID, we had made a test compared to each type of setup from from the front side and rear side. We made both EVA and the EVA plus EPE, EVA plus POE, or EPE plus EPE, or POE to POE. You can see for the PID issue, for sure, POE is the best. Later is EPE plus EPE. Later it is EVA plus POE, but this is similar to EVA plus EPE. And the worst one is EVA plus EVA. So for the cost reason, people start to move from EPE plus EPE to EVA to EPE. Yeah, this is getting more and more popular solution for the manufacturer selections. Also, you know that now the wafers start to be thinner, and the ribbons start to be how to say it, getting round and larger diameters. So the wafer cutting, if not perfect, you always get a cracking at this area. So CYBRID is creating a new type AB structure or ABS structure to solve these micro crack issues. We had data to show that the clear EVA compared to our co-extruded white EVA, we had 4.3 watt power increase. Later, we had the investigate the micro crack issue from the first generation, second generation micro crack comparison, that the micro crack reduced to 70% using the co-extruded EVA type. Yeah, this was a major mostly preferred by the half cell module technologies. Yeah, now this is a short summary that we can go is the general development of Backsheet PVDF and the encapsulant film has showed a trend of improving performance and market trend. Also for the bifacial modules using transparent Backsheet, it's better to consider abrasion property and the sequential aging test. Yeah, also the third one is high reflection black Backsheet has 2.15% power gain, and aging test shows it is stable. And now this is going to larger scale application, also for the rooftop modules. Last one is now it is more and more getting interesting for the co-extruded EPE and the second generation white EVA for both PID and the micro cracking issues of the large cell modules. So thank you.
Thanks, Stephen. Very interesting. I think that's probably the final nail to finish our Backsheet survey. So yeah, Fravan and was probably looking very eagerly for your presentation. Thanks a lot. Quick question from my side. What about the fluoro-free PET-based product that you're having? How big is this, and how important is this, and how much are our customers interested in that? So I think in China we've also seen, as I understood, some price increase for traditional PVDF based backsheets, because they are also needed for some other applications. So and due to sustainability, how much is the interest here?
Yeah, you're right. The PVDF has increased the price a lot during this period. So yeah, PVDF backsheet is really preferred by the Chinese big module makers and also the installers. They preferred fluoro-based backsheet because they think it is more reliable and 35 years guaranteed always. For the fluoro-free backsheet, it is always that was the request from Europe and also other countries, because Europe has the restrictions for the environment-friendly products, and also for the European, most of the modules was mainly installed on the rooftop. So the module makers like Trina and also others, they had introduced this non-fluoro backsheet modules to the European market. So this was widely accepted by the European customers. So this is a good volume each month, about 2 million, 3 million square meters for CYBRID. The rest of backsheet was always a KPF or both fluoro coating based FPF backsheet. Yeah, I think due to the cost reason, people are thinking for cost down, they would like to choose a cheaper backsheet like non-fluoro. It is okay, but they are selecting case by case, not for all the projects.
Okay, interesting. I think so we're running a bit out of time. I think there's a couple of questions, Stephen, in the chat. It would be nice if you could answer them there in written form. That would be very helpful. If you see that.
Okay.
Yeah,
I see this. I see.
Okay, super. Then thanks so much for this insights into module packaging, a very important topic. We will soon come out with our market survey on backsheets, really in the final, just working on the final touches. And then you can also get more insights into that. So